everybody can hear me. Can somebody confirm if the audio is okay?
Yes, the audio is okay, Rajesh.
Hello?
Hello? Yes, the audio is okay.
Hello? All right, so welcome to today's webinar on DevOps on AWS. In these times, I hope everyone is keeping safe and healthy. Today, we will talk about DevOps, creating your own DevOps practice, and how to implement it on AWS and using the tools that AWS provides, and how moving to a microservices architecture can help enhance your DevOps process. DevOps is a very vast field, so we will try to make it as simple as possible and keeping a general audience in mind. So before we start, let me introduce our team that will be presenting the webinar. My name is Rajesh Soman, and I am a director at Integra Technologies. Along with me to do the presentation, I have Hazak Naeem, who is our head of technology services, and I have Amaljeet, who is our senior DevOps engineer as well today. Now, a brief intro about Integra Technologies. We were founded in 2006 and primarily focused on enterprise open source solutions. Today, we are an AWS Advanced Commercial as well as public sector consulting partner for this region. We're also a premier partner with Red Hat, but we do support all other distributions like Amazon Linux, SUSE Linux, Oracle Linux, and also the entire ecosystem that runs on these OSs like your MySQLs, your Cassandras, Nginxes, Apaches, etc. We support Microsoft technologies as well, and we have a fully certified team of AWS, Linux, and Microsoft engineers in our team. Our team is completely based in Dubai. That's an important point to note. All our resources are local, and we provide the entire solution lifecycle. We do consulting, implementation services. We do support as well as provide 24/7 managed services as well. So moving on, over the years that we have been providing AWS services, we have focused on a few areas, and we have matured practices in those areas, DevOps on AWS being one of them. We have helped our customers move from traditional methods of infrastructure and application delivery to a DevOps-enabled process. And the result is a faster go-to-market, increased customer retention because of newer features that are added at speed, and the whole process of DevOps creates greater in-company collaboration. So these are a few results that we have seen when DevOps is implemented. We also have a practice of, we concentrate on a practice for migration of your workloads to AWS from on-prem, including all-out migrations as well as phased migrations, and supports all technologies, Windows, Linux, your Oracle, databases, applications, etc. Also, we have a security practice where we can evaluate, monitor, and manage security on AWS for you. We're also part of the AWS well-architected program, and we make sure that all of our architectures that we design are well-architected as far as possible. As far as possible, because not all of the pillars or all of the cases may be suited to a customer implementation. But after implementation, we also conduct well-architected reviews with Amazon solution architects as well. We can do that for your existing architecture as an independent third-party well-architected review as well. and you might be eligible for benefits from Amazon in certain use cases. We're also excited to announce that this week we have launched our new practice that is on machine learning and IoT. It's available at www.integratech.ai. So basically, over the last few months, we've been working with some of our customers to work on their use cases. And as part of that, we have worked on automating insurance claim for vehicle damages. If you images onto your right, those are basically detecting damages on your vehicles. So the image on the top was when we had not trained the model adequately, but with constant additions to for training the models, you can see that the detection rates have increased significantly. So we're working on connected vehicle projects as well. So that's a topic for another webinar some other time. Now, so this is these are some of our existing customers who are on AWS, who have some of them have implemented DevOps practices as well fully. And this is just a small subsection of our customer list. We're also very strong in the financial services sector via Red Hat line of business. So now basically I will just hand over the presentation to our DevOps engineer Amarjit, who will take you to the most important part of this seminar. Thank you.
Thank you, Rajesh. Good morning, everyone. My name is Amarjit. I'm a senior DevOps engineer with Integra. So just before we start on to the core of the presentation, this presentation has been created keeping in mind that there will be a mix of technical and not so technical audience. And if you have any questions, please put it on the chat window, so we'll be addressing it by the end of the presentation. Okay. So let's start, and the agenda is like we'll be briefly discussing on what DevOps is and how we can do it with AWS Cloud, and what are the offerings from AWS specifically on DevOps. And there will be some few examples on how we can practice better DevOps with AWS Cloud. Okay. Okay, so let's begin with the classic definition. So as the definition goes by, DevOps should be something like the following. So it's a combination of cultural philosophies, practices, and tools that increase an organization's ability to deliver applications and services at high velocity. So if we perceive, it can be seen as an extended version of agile process, and it really focuses on delivering high quality applications to market as fast as we can. But with the advent of cloud technologies, both private and public cloud, the focus has been shifted more to automating infrastructure provisioning and also to the continuous integration of applications. And we generally call it DevOps, but traditionally the security approach is also on the focus. So the general approach will be developers or application developers will create the application, then hand it over to the security team to do further analysis, and then they come with feedback. But here in an integrated approach like DevOps, security has to be in line with every step of the process. So that's why DevOps can be sometimes called as DevSecOps as well. Okay. Okay. So now a question many of us might have in our mind, like, do we really require cloud for practicing DevOps? So technically the answer is no, we don't need cloud to practice DevOps. But cloud is a stronger combination in terms of adoption and practice of DevOps. There are many reasons behind it. For one, the cloud enables you to start your infrastructure development, deployment. It helps you to start smaller and within a matter of minutes to start. So we can say we can do implementations within hours, and we don't need to. There is no more wait for to the in the traditional way of like bringing the hardware and configuring it and waiting for the operation teams to provision it. So everything is like point. We can build at scale. So whether we have a product or a software application which has few hundreds of users or millions of users, so the cloud offers us near unlimited capacity. So we can, whatever the scale is of our application, we can host it with the cloud. And coming to the next point regarding automation. So from the inception of the project, from the moment of code, whether it is the infrastructure or application, from the coding and the commit and the test, so the entire process, the entire software development lifecycle can be fully automated with the available tools and services from cloud. And coming to the infrastructure as code, which is a very famous buzzword these days. So we can even consider the infrastructure or the infrastructure which can be converted as software code. So we can version control it. We can launch infrastructure using it. So that is the automation and infrastructure as code goes hand in hand. Coming to the huge partner ecosystem, so we can deploy applications or infrastructure immediately from the marketplace, which is available with AWS Cloud. Say, for example, we want to deploy a firewall in the AWS directly from the marketplace, which is like a ready-made solution. Okay, and the best bit, we don't need to invest upfront. There is no more guessing capacity and capability. So you can start with a well-architected environment, and as and when the demand increases, as and when your user base, your application grows, you can scale it. And almost all of the services from AWS are designed and created keeping DevOps in mind. Okay, so let's quickly discuss the advantages. So when it comes to practicing DevOps, collaboration is very crucial. This means that the devs have to work with the ops and the security and testing, since everything is interconnected. So naturally, this leads to a greater interaction and very less friction between the teams. And having a good DevOps practice and implementation of CI/CD process will greatly help you deliver features and enhancement which will happen very quickly till the production. And you can deploy anytime. There is no more long nights waiting for the traffic or the load to come down. You can deploy multi-deployment methodologies like Canary, which means new features are rolled out only to only a small percentage of users, and based on the feedback received, can be deployed widely or we can roll back. DevOps practice means that all teams work together, and within teams, everyone gets a part to play. So there is no more heroes in the organization, whether it's a star developer or a star security tester. And security is the topmost priority here. And to ensure this, while developing a proper DevOps practice, the security should be integrated in every part of the process. So we will see that how that can be done in a later slide. And the last point, there will be instant feedback at any given point or phase of the DevOps software development lifecycle, so which will be carried out with continuous monitoring and feedback. Okay. So this slide just embodies the philosophy of DevOps, like I explained. It covers the entire lifecycle of software and infra from planning to operation, with the operative word or the buzzword being fast. Okay. So like we discussed, DevOps seems wonderful. It is indeed a buzzword. But before jumping into DevOps adoption, The set of questions we should ask ourselves are, do we really need DevOps, or are we ready for the change, or do we need to invest in tools and the tech? So DevOps adoption hugely demands change in culture among all the team members. So how willing are the management to induce the change and convince all the stakeholders to collaborate and break the functional barriers? And the next important point, investment. So what is the return on investment expected if an enterprise were to adopt DevOps? Sometimes it may make financial sense immediately, and sometimes it may take years of investments and efforts to get a return, a proper return. So let's get into some examples. So let's say we have a simple WordPress website for our product X. Let's say we update the website once in 2 weeks. So do we need to have a DevOps practice here? So is it worth investing time and just for the sake of making it sound fanciful? The answer will be no. So let's take, because it's a simple WordPress website, let's take another example of a fitness tracking app company. So they might have hundreds of thousands of users connecting from hundreds of different device types. So the software compatibility, the integrations, the tracking or new feature additions or bug fixes. So the entire software development lifecycle will be active, and there might even be multiple rollouts within a day. So yes, this is a perfect candidate for adopting DevOps. So another example, a fintech company. So since it is a fintech company, they need to have consistent customer facing applications offering the highest level of security, and app features rollouts may be very lesser in numbers, but code validation, build security, deployment validation, etc. are of the paramount importance. So we say yes, mandatorily DevOps adoption is required. Okay. More example, as you see in this diagram, right from when you do the planning or design, you have to model the threats that could affect your business, and you should come up with policies and standards. Testing of the code must be done. And coming to the build part, third, and patched. So during the test phase, vulnerability, dynamic testing, which is also black box testing, and penetration testing must be done. Once the application is approved for release, checks must be done for complaints. And once it is operational, the ops team has to be constantly aware the threat landscape and must use tooling to predict, model and emergent threats. So all these can be linked with AWS Security Hub. So that single pane of glass view is available for all teams. They should monitor and detect infiltrations or compromises so that we can respond and recover from any attack. So this process, as you can see, it's a continuous cycle, but this helps in making your app a very secure one. Okay, quickly moving on to the tools and services offered from AWS on DevOps. So let's see, these are the products or services which is focused on integration and delivery. AWS Code Pipeline is a continuous delivery service from AWS that builds, tests, and deploys source code consistently and automatically based on the release process model we define. And Code Pipeline integrates with Code Commit as well as GitHub or Bitbucket which are the popular source code management systems. And next one, AWS Code Build is a fully managed build service that compiles source code, runs tests, and produces software packages that are ready to deploy. So with code build, you don't need to provision or manage or scale your own build servers. For each build, carry out routine management tasks such as OS patching. And AWS Config is an Amazon Cloud auditing tool that provides an inventory of existing resource, allowing an administrator to accurately track AWS assets to analyze compliance and the levels of security. So it also enables an administrator to troubleshoot why a resource may have stopped working properly. Okay, moving on to monitoring and logging offerings. So AWS CloudWatch is actually a service intended for monitoring AWS resources and applications you run on AWS. CloudWatch enables real-time monitoring of AWS resources such as EC2s, RDS database instances, load balancers, etc. You can use CloudWatch to collect and track metrics, collect and monitor log files, or to set alarms and automatically react to changes in AWS resources. Okay, sorry about that. Okay, so let's continue with the monitoring and logging services. AWS X-Ray. X-Ray is a service that can help keep track of applications and user requests within an application. It's a debugging tool, so that works with production level apps. Those are in build or test phase. So it'll trace all the microservice requests and work with all services like EC2, ECS, AWS Lambda, etc. Coming to AWS CodeTrail, we can log, continuously monitor, and retain account level activities, all the actions related to your AWS infrastructure. Okay, moving to platform as a service and version control. So Elastic Beanstalk is a cloud deployment service by which we can easily set up your application or on your infrastructure simply by just uploading the code. So all other necessary operations like auto scaling, provisioning, load balancing, and application health monitoring, etc., will be handled by Beanstalk itself. And it also supports a wide variety of platforms like Go, Java, Node.js, also Docker, and web servers like Tomcat, Passenger, etc. And AWS Code Commit is a fully managed source control service that hosts secure Git-based repositories. So it makes it easy for teams to collaborate on code in a very secure and highly scalable ecosystem. Okay, so let's discuss how we can, how DevOps will help us in practice. Okay, the S-curve diagram, which is seen here. So this diagram depicts the collaboration versus the value when we practice DevOps processes across different phases. So we can see there are phases starting from plan till operate. So let's look at the bottom of the graph. We'll start with traditional agile development. So this provides least value and which is least collaborative, because it is covering only till the build phase. And this will mostly practiced only for development activities. Okay, the next one, which is slightly more collaborative and provides more value, which is continuous integration. So developers integrate their code into a shared repository several times a day in order to obtain rapid feedback or the sustainability of the code, so which can be through automated build and testing. Next one is continuous delivery. The tested code is built and deployed till the last stage environment, and which will be ready to be deployed to production. And once we get the manual go ahead by the appropriate authority, so we can see that last is still the release. And the next one is continuous deployment. So here, the qualified changes are deployed to production as soon as they are ready through an automated pipeline workflow without any human intervention. So this is the fastest and most collaborative DevOps practice. Okay, so in this diagram, like we discussed in the previous slide, the first four parts, plan, code, build, and test, will contribute towards continuous integration. And we can see there is a feedback loop between code and build. There will be multiple builds happening in a day and the code changes. So that's why the feedback loop is 4. And if you see the second half of the picture, starting from test, release, deploy, then operate, this will be the continuous delivery part. And there will be another feedback loop between release and deploy. There can be multiple releases in a day to multiple environments. That doesn't mean that we should put all the releases to the production. So if you see as a complete thing, this will be called as continuous deployment, which will then be used to deploy till production. So let's see the tools or services offerings in each section. So AWS Cloud 9 is a IDE, integrated development environment for developers. And as we discussed in the previous slides, there is code commit, code start, also code deploy, X-ray, elastic beanstalk. So we discussed all this in the previous slides. Okay, so let's look at an example workflow. So this is a CI/CD pipeline that deploys an application or a Docker container to Fargate. So we have a shared account which hosts the repository and will be responsible for the pipeline deployment and will host all the necessary secrets and parameters for deployment across different accounts. So we also have multiple accounts here for development, test, stage, and production. So it is not necessary that all these be in separate AWS accounts. It can be all in one account as well. However, having different accounts reduces the blast radius. So once the code is committed to the repository, a pipeline request is triggered. The pipeline is defined in code pipeline. So this code pipeline, this will be the coordinator. This coordinates the automated flow and the transition right from the repository through build till the deployment. So the CI/CD pipeline can be used for code deployment as well for provisioning or managing the infrastructure, which is the IAC concept. So in this example, where I want to deploy my container-based application, the developer commits the code to the respective branch in the code commit. So once the pull request is reviewed and approved, the pipeline then triggers the build process using code build. So which creates or builds the artifact in this case. In this case, the artifact is a Docker image, and it is pushed to an Elastic container registry, from which it can be later deployed onto the development account. Any updates to the infrastructure can also be deployed using infrastructure as code, the CloudFormation template. So once automated tests ensure the quality of the pushed code or the application code, the second stage of the deployment happens. So the application is now pushed on to the test environment and then to the stage, and either automatically or manually deployed to the prod environment which is a subject of approval. Okay, let's see how a typical security pipeline will be. For example, let's consider a Docker deployment process. So there will be pull request. If you see on the top left of the diagram, the first thing is the pull request. So the developer commits the code to the respective branch in the code commit. So once the pull request is reviewed and the code is merged to master or production branch of the code, then the code pipeline is getting triggered. You can see an arrow going down to the pipeline. So the code pipeline initiates the build process. Within the build process itself, it does Docker linting. So it actually checks for optimizations and likely failures, resulting in a cleaner code, no errors, and possibly a thinner or a relatively smaller Docker image as a build artifact. So there are several Docker file linters available. One of the most popular one being HadoLint. So we can use that for Docker linting. So in the next step, it does secret scanning, which is basically checking the build artifact, the container image, for any access key, secret keys, or any credentials that might have slipped in. So this is necessary as part of the PCI DSS compliance. So we can use open source tools like TruffleHog and Git secrets for doing this secret scanning during the build process. And in the build process, next step, it does common vulnerability scanning. So vulnerabilities are scanned in the Docker image using open source tools like Anchor. So there are many tools available. So now there are two possibilities. So in case there are vulnerabilities or exceptions found, then the code build pushes the details to AWS Security Hub. So Security Hub is a place where all security issues can be logged, viewed, and acted upon. So it can also trigger a CloudWatch events rule. You can see the arrow going up. And so the events rule would trigger a Lambda function, which can then provide instant feedback to the pull request in the repo, saying that because of this code change, such exceptions occur. So if the security process comes out very clean, there are no exceptions, then the code build pushes the image to the ECR, Elastic Container Registry, and all is well. Okay, so with this, I am handing over to Hasak Naim, who is my colleague, and he'll be talking about how to re-architect for DevOps and the cloud.
Thank you, Amal. And hello, everyone. My name is Hazik Naim, and I am a Technology Services Manager at Integra Technologies. In the previous section, we discussed the concept and practices of AWS and saw the different tools that are available in AWS to help you adopt the DevOps practices. In this section, we will discuss re-architecting applications and some of the tools that we can use while we are re-architecting the application for deploying on AWS. Generally, application architecture are divided into two categories: monolithic application and microservices application, or tightly coupled or loosely coupled applications. DevOps tools and practices can help enable both monolithic and microservices-based applications. But going forward, I will try to show you how having DevOps practices truly complements microservices-based architectures. So what exactly is a monolithic application? A monolithic application is built as a single unit. The design philosophy is that the application is responsible for performing every step needed to complete the application functionality. Since monolithic applications are built and deployed as a single unit, we have to be careful of dependencies between different functionalities and different features and libraries, as they might create package conflict and dependency issues. For example, a new plugin might require a newer version of Java, while the older plugins might have dependencies which are not yet ported in the newer versions of Java or might be deprecated. Adding a new feature or enhancing existing functionality requires you to redeploy the entire application. This will mean that you will have to run QA testing and unit testing on the entire application and need to redeploy the application itself. This may lead to downtimes and non-availability of the application. The failure of a single function or a module, or even the presence of a single security vulnerability, could lead to the failure or compromise of the entire application. Monolithic applications tend to be less fault tolerant, and building these fault tolerance in the monolithic application is relatively more difficult. Development and maintenance of these applications are also done as a single unit, and this normally leads to code sprawls and huge code app sizes, which are hard to develop, maintain, or even debug. Here we have an example of architecture of a typical monolithic application. The example ecom application shown here have multiple different functionality all bounded together as a single unit. It communicates to a single database, and client communicates directly to the front end. All in order to scale this application, we'll have to scale the entire unit. We'll have to scale the entire application altogether as a single unit. And what are microservices-based architectures? So unlike a monolithic application, a microservices application is one in which the functionality is broken down into smaller pieces, distinct and discrete pieces. Generally, it is broken down based on the functionality of a service. Since these services are independent of each other, they are also maintained and deployed independently. These services will have their own repository and their own deployment pipelines. Dependency of one microservices will not collide with another. In fact, they can even run on different platforms if required. Services can now be easily loosely coupled, either by using APIs or using messaging services such as Amazon SQS, or even any of the open source based tools like Apache Kafka or RabbitMQ. This helps and add fault tolerance in our application, and thus higher application availability. Scaling the application becomes much more efficient now. Instead of scaling the entire application, we only scale the component that has the highest amount of load in terms of network, CPU, or memory. As I mentioned earlier, these services can have their own repositories. This gives us the ability to have faster deployment cycles. Instead of testing the entire application, we only perform unit testing on a single service. This gives us the ability to deprecate services easily, unlike in a monolithic application where dead or deprecated code would hang around the application throughout its life cycle. So how do we transform a monolithic application into a microservices-based one? I'll give you the bad news first. Converting your application into a container will not suddenly make your application into a microservices-based one. A common approach would be to identify functionality that is non-critical or may already be loosely coupled. Once the service is identified, it could be deployed separately, isolated from the main application. The communication between the services are done over API gateways. Ideally, the newly created service should have its own database and should only be reachable over the exposed API. If a functionality that needs to be added, a new API would be added as part of the application. Here we have the same e-com application that I showed earlier, which demonstrated a microservices-based architecture. As you may notice, an API gateway has been added as a new functionality in the application, which acts as the backbone of communication between all the services, including client communication and the front end communicating to the back-end services. All the services also communicate with each other through the same API gateway, and each service now has its own database. Next, the same architecture using some of the AWS provided services that we can integrate quite easily. For example, the Amazon API Gateway, which is a fully managed API gateway offering from Amazon. The developers don't have to worry about developing their own API gateways. They can just integrate Amazon-based ones. Authentication can be done through something like Amazon Cognito. Some of the services like notification can be triggered using SQS, Lambda functions, and SES. Front-end can perhaps be hosted in an Amazon S3 bucket. So is it simple to move from a monolithic application to a microservices-based one? Well, that depends on the application, how bloated it is, and what functionality the application performs. Some of the things that one must consider before contemplating a re-architecture are, should each of the microservices has its own database, or can they share the database? What about the technology stacks? You could use PHP for one application service and Python for another. Or you can even use newer technology stack for newer functionalities like Node.js or Golang. Once you have many microservices, how easy are these to manage? What was once a code sprawl has now become a services sprawl. Tools like load balancer and service discovery can help mitigate these complexity to a larger extent. Every microservice should be constantly monitored. As these microservices scale in and out quite rapidly, monitoring them becomes more essential. And classical monitoring tools are just not cut out for these kind of monitoring solutions. How do you handle lots of data or lots of microservices talking to lots of different services among themselves and to the database? Each microservice can be handled by a different team. This can help increase the speed and deployment, speed of deployment and pace of innovation. On the other hand, how many companies can afford to have different teams for each microservice? So a balance has to be found. Having many more repositories and even greater number of services, it becomes nearly impossible to build, deploy, and test your application with a manual approach. So a continuous delivery, a continuous deployment framework must be adopted. At an organizational scale, there could be hundreds of different pipelines doing thousands of different deployments every day. Mastery of the key DevOps concept is very important. Here we have an architecture which is based out of AWS Fargate. Once an organization has adopted the microservices-based framework, it is easy to go serverless. The AWS offering of AWS Fargate makes it quite easier to move your containers to a completely serverless-based environment. Some of the AWS services that you can tie into your microservices ecosystems are shown here. API Gateway is a fully managed service that makes it easy for developers to create, publish, and maintain APIs at scale. AWS Lambda is, of course, the serverless offering from AWS. Next, we have the AWS ecosystem for containers, which include ECS and EKS, Docker-based containers, as well as Kubernetes-based containers. Then we have the DynamoDB, Aurora, RDS, and Elasticache, the data stores for your microservices. AppSync is a GraphQL-based API service, which is fully managed by AWS. And finally, X-Ray, CloudWatch, and CloudTrail to monitor, track, and trace your applications and your account. Microservices bring additional functionality to DevOps by embracing common tool sets, which can be used for both development and operations. These common tool sets establish common terminologies as well as processes for requirement, dependencies, and problems, which in turn makes it easier for devs and ops to work with one another, allowing these entities to work jointly on a problem and successfully fixing a build configuration or a build script. DevOps and microservices work better when applied together. Finally, we have a demo prepared by Ahmed Qazi, who will demonstrate some of the tools and concepts that we have talked about earlier. Over to you, Qazi.
Hello everyone. I hope you guys can hear me well. Just a second. I need to get my. Can't see the screen. Just a minute. I believe you guys can now see my screen. Okay, so again, hi everyone. It's good to have you all over here. My name is Ahmed Qazi, and I'm a solutions architect at Integra Technologies. So I'll be walking you guys through a demo on CI/CD pipeline. So let me just start with the diagram. So this is the diagram. Over here we have a demo architecture. So a CI/CD pipeline, as you know, it needs a source and a destination. We'll be building the CI/CD pipeline through code pipeline, and we will be using a lot of AWS code services such as code commit, code deploy, and we'll be deploying it on a EC2 instance. So this is a whole process. Code commit and code deploy, they work in conjunction with code pipeline. So as you can see on the diagram over here, as soon as a developer commits a change, it is committed into the code commit, and then it is automatically deployed through code deploy to your EC2 instance. It's an in-place deployment. Due to time constraints, I couldn't, I had to go with the basic pipeline, but hopefully next time I can have a blue-green deployment with a much more complex or a multi-stage pipeline. So I will start with the demo now. Let's log in into my AWS account. Okay. So the first thing for a pipeline is that we need to have a source. So in our case, I'll be using code commit as my source. So this will be my repository. So over here, I have two repositories. I'll just show you guys how to create a repository through code commit. Now, new demo repository. Add some tags, name, CI cd and okay, I cannot use this. Why is this? It already exists. Okay, sorry about that. Yeah, it's created. So the great thing about code commit is you can integrate it with your IAM policies. So one of the scenarios can be, for example, if you have an AWS account, right, and you have a lot of developers and you have a lot of repositories, with IAM policies you can restrict certain developers to certain repositories and even branches. So it is really well integrated with a lot of AWS services. Over here, I have a repository called new demo. I created it. So just like any other repository, you can generate your credentials. You can, using the Git commands, you can upload your code to your repositories. Over here, I have already uploaded the code. It's just a simple HTML page. Now this is our source. Now you can, obviously you could go with S3, you can use GitHub, Bitbucket, you can have multiple sources, so that's the first thing. Now since our source is ready, the next thing would be to have our destination ready. So in my case, I'm going with EC2, Amazon EC2 instance. You can choose, on-prem server as well. You can choose an AWS Lambda as well. You can deploy on Lambda as well. You can deploy on an ECS container as well. So let's build our destination. That would be my EC2 instance. Running instances. Okay, I already have one. So we'll just create an instance from scratch. I'll go with Amazon Linux AMI2. General purpose, this is fine. This is fine. I'll have to create an IAM role. Now this is quite important over here. So I already have created, lot of IAM roles, but for the sake of the demo, I'll just go into details and I'll tell you the importance of this role. So I'll create it now. Okay. Let's create a role. We have to add policies. We have to choose EC2 instance because this is going to be an instance profile. Next, we need to add some policies. So this is important. Why I had to go through this and show you guys. So we need to add permissions for code deploy. Okay. I'm going to give it full permission. So the reason why this permission is important, because we will be having a code deploy agent in our EC2 instance. So it needs permission to talk to the code deploy service, right? The agent in the instance will need to talk to the code deploy service. So this is why this is important. Then we'll have pipeline access. Is for the pipeline, so that pipeline can also communicate with our EC2 instance. And just for debugging purposes, I'll be giving full SSM access. Now we could fine tune these permissions later onwards, but since this is a demo, I had to go with full permissions. So let's give it a name. CI/CD role. Okay. Okay, so the role is created. I'll just refresh this IAM role and it should pop up over here, CI/CD role. So this is it. Now, as earlier I told you guys about the agent, right? So I need to install the code deploy agent as well, so that it can detect whether there is a deployment or there's a change or not. So let's just use this script. I got this script from the AWS website. Okay, you guys can use this script to install the code deploy agent, and this is fine. Security groups. I'll go with this. It's open to the world, but just for this demo, after this, I'm deleting it. So launch, I have a PEM key with me. I acknowledge. Thank you very much. So the instance is being launched, and which is my tag? This is my tag. Okay. So now the source and the destination are already created. Let's just go through the diagram again. Slide two from the slide. So we are done with this part. Our source is ready. Our destination is ready. So what is remaining? It's code deploy and the pipeline. So we need to create a pipeline and we need to configure our code deploy. So I'll go into detail when I start with code deploy. Let's wait for the instance. Okay, the instance is ready and it's running. So let's configure code deploy. If you guys have any questions, right, you guys can type it in the Q&A and I'll answer those questions once I'm done with the demo. So this is code deploy over here. I hope you guys can see it. Applications. So we'll start by creating the application. Let me tell you a bit about application. I'll call it CI/CD app. And this is a compute platform over here. So as I told you guys before, you can deploy it on EC2, on-prem. On-prem will have a different agent. You can deploy it on AWS Lambda. You can deploy it on ECS as well. So I'm going to choose EC2 because that's my destination. So once this is created, right, now we have to create a deployment group. So you can have multiple applications. For example, you want the code to be deployed to ECS, you want to deploy to AWS Lambda or EC2, and then inside that you can have multiple deployment groups. So for example, you can have an application group for your prod, you can have application group for your deployment, for your development, sorry, staging. So let's call it CI/CD demo PG deployment group. Now we have a service role. We have to give it this role. Then we have deployment type. So I told you guys before, due to time constraints, I'll go with in place because it's much more faster compared to your blue-green. Then we have Amazon EC2 instances. Okay, now I look at this. It says 0 unique matches because the deployment groups, they identify the instance using name tag. So naming, tagging is really, really important, not just for this, but it's also a very good practice to tag your resources. So you can use cost allocation tags and you can, get more information about your resources. So what was the tag which I created? CI/CD demo. Here it is. So it should find, the instance. So now it says 1 unique instance. So let's see that it is it the right instance? Okay. Yeah, this is the right instance. Yep, this is it. Okay. It was just created today. That's good. So now this is done. We have 1 unique instance. We'll deploy all at once. Okay. You can have different type of types, or here 1 at a time. If you have, a lot of instances, you can deploy to 1 instance at a time, or you can deploy if you have 2 instances at one time and then 2 later onwards. I won't be using a load balancers because I'm just using a single instance. So if you have a load balancer, then it will, stop the traffic and deploy to that instance, and then, it will balance the load. So the deployment group is created. Okay, that's good. Now, the last thing would be to have our pipeline ready. Okay, and let's just show you guys this diagram once more. So code commit is done, code deploy is already made, Amazon EC2 instance is set up. What we need is the pipeline. So the pipeline is the umbrella. It shadows all of these technologies. So we have the pipeline, and with pipeline all of these things will work together. So let's just create a pipeline now. CI/CD demo service role. This is the service role. If it needs to communicate with other services, it can use this role. We'll go to advanced setting. Your artifact, it builds an artifact that will be stored in your S3 bucket, and we are going with the default AWS managed key. We don't need to use our own KMS key, although you can use your own key if you need to. Then we'll go with the source provider. So as I said, source is important. You need a source. You have ECR, S3, Bitbucket, GitHub. In my case, I'm using code commit, and it will just automatically show you the repositories. So my repository was new demo because my code is in that one. I'll go with the master branch. You can have multiple branches over here. Then you have for change detections, you have AWS CloudWatch events and AWS code pipeline. Now the pipeline will detect the changes periodically, whereas the CloudWatch events, they will automatically detect. There is no period set to it. It will automatically detect. For example, if you have a code commit change, you commit something in your code commit repo, it will automatically detect it, and it will push those changes to your EC2 instance or your ECS or Lambda. So next, builder 2. Now this is one stage that we don't have over here. I skipped it because we have a simple HTML page over here. So if you have an application that requires building, you can have code build the entire thing for you, but I don't need it, so I'll just skip it. So you have Jenkins and code build in this. You can use it with Jenkins as well. Next, yes, skip. Deploy provider. So I will choose code deploy because this is what I'm using. I'm not using CloudFormation or Beanstalk. You have a lot of deployments. It's in Ireland region. I'm using Ireland. Yes, and then I have to choose my application name. So what was my application name? I forgot. CI/CD app. No CI/CD. It is this one. Yep. Now we have the deployment group. So just like this, you can have a lot of pipelines, multiple pipelines with multiple applications group, multiple deployment groups. It can get really complex. It depends on your use case. This was just to give you a gist of how a pipeline works. So let's just create this pipeline. It's taking a while. Now it's done. So as soon as it is done, it is pushing the changes in my code commit to my, this one, code deploy. I can even have permissions over here. I can get notifications if I want to, at what stage the pipeline is, whether it failed, whether it succeeded. Now it detected this commit. This was the latest commit. It works with the commit, and now it will deploy my changes to my EC2 instance. Let's go into details. Hopefully it will work. Okay. Wow, this was pretty quick. It took like 8 seconds and it's done. Let's see, go to the events. Oh, everything passed. Let's see the instance. This is my instance, right? So let's go directly to the public IP of my instance and let's see if the code deployed is working. Yeah, it's working. So I had it done earlier. So let me change it. Let me show you how code commit automatically detects the change. So I will have today's date in my code commit. Let's go to code commit, repositories, new demo. This is my index HTML. I'm changing it over here. You can obviously use CLI and you can use it in from your own system. I'm just using this because it's easier. So today's date is 21 April. And the time is 12 p.m. in the afternoon. Let's call it revision 2. Name, my email ID. If you have any questions, you can, obviously email me. New change. Done. So now the pipeline should be automatically triggered. It will detect this new commit. Let's go to the pipeline. Okay, so just 1 minute ago. Let's see this new commit. The commit is there. So I'll just identify, is this my change? Let's see. Yes, this is the right one. Let's go to the pipeline. I believe it's already deploying. I saw it. So, yeah, it is in progress. It is deploying to my EC2 instance. It is deploying this change. So let's just wait a bit. Yep, it succeeded. I'll just directly refresh my page. Yeah, there it is. So this was a very basic, simple pipeline for you guys. I hope next time onwards I can create something much more complex and you guys can ask questions. So that was about it, and thank you very much. Over to you, Rajesh.
Hi everybody. I hope this session was of use to you. Meanwhile, if you have any questions, you can use the Q&A tab to raise them there. If not, we will be sharing our contact details in an email that's going to come to you possibly today or tomorrow. And then you can get in touch with us and then have any of your questions answered. In the meantime, we'll wait for a few minutes in case you have any questions. We can get that answered right now. Yes, of course. Redington would be sending you the link to the recording of the webinar. So probably today or tomorrow you will be getting the email, and it will have our contact details as well. So you can give us a call or raise any questions through email as well. All right, thank you. I guess we enjoyed it as much as you guys did. So yes, Jojo, yes, yeah, the slides will be shared via email. You'll receive an email soon. All right, then I think we can end the webinar today. I think it's getting time
Yes,
for lunch
Raj.
now, so we won't keep you much more. In any case, any questions, like I said before, feel free to get back or get in touch with us, and we will be happy to answer them for you at any
Thank
point
you.
in time.